then you will have to not participate verbally, but you are still welcome to attend or watch it later, however you prefer. So let's start by introducing. This is a PostgreSQL meetup. This is the first cross-group meetup between the Polish user group and the Swedish user group. So I will start by introducing the Polish meetup. So this is the first Polish Postgres user group established 3 years ago in 2017, currently gathering 873 members. Today is the 20th event, and because of COVID, we switched to the online format a couple of months ago. We are welcoming all the people that would like to give a talk on our meetup, and please just ping the organizer on LinkedIn or on our meetup page, which is the main contact form. And we also have a YouTube channel that contains all the recordings from our previous meetups. Before I give hands to Georgios, I would like to apologize for looking to the side. That's where my screen is, and I am on the phone. So please forgive that I'm not looking directly at you. So after you, Georgios.
Thank you. I'm Georgios, and I represent the Swedish Postgres user group. We are active for quite some time, but I don't know for how long. I know that I have been helping organizing the last year and a half, but I have been in some events the last 4 years or so. It's quite some time. We're very happy to see old faces, but we have seen some first timers. For you that you joined for the first time, I would also like to add that we are always looking for people to help out or to present. And if you want to take part in any possible way, please don't hesitate to reach out. Now, having said this, I would like to talk a little bit about the format of the discussion we're going to have here with our guest, Andres. We're going to try to have like a short discussion where we are pretty much asking some few questions that we have gathered either from our members from that meetup, or we have come out for them ourselves. We're going to try to keep it to 1 hour, and we're going to try to give at least 10 minutes for a Q&A in the end. If people have some question that they would like to interject, they should feel free to write it in the chat or raise their hand at the end of the discussion, just in order to be able to navigate a little bit easier. Please raise your hand if you would like to ask a question, and then turn on your camera. During the talk, we would ask you to please turn off your camera to help with the streaming for the people if you have turned it on, and to mute your microphones. Thank you very much. And now back to Adam.
Yeah, so a short introduction of our guest. We are joined by Andres Freund, and please correct me if I butchered your name.
You didn't.
Thank you. Andres has been a contributor to PostgreSQL for over 10 years and a committer for 6. He has concentrated on replication, performance and scalability, storage, and patch review. Do you want to add something, perhaps, Andres?
No, I think that's a pretty good summary.
Okay, so we are off to the general questions. Georgios will start.
Thank you. So my first question would be like, you are a European and you have moved to the US. How did you find that transition?
I think it was easier in some ways and harder in other ways. I think I lived in Berlin. I lived in Berlin before, and moving to San Francisco, and the day-to-day experience is actually not that different. It's more the longer-term organizational things that are really weird. Healthcare, some other bureaucracy stuff that I just take a while to get used to. But it was, yeah, it was less hard than I thought it would be. And I think the other thing is that for a European, it's very hard to imagine how empty the US is. Like, there's just so much space, like outside of San Francisco, but like it's very hard to understand from like as somebody from Europe.
Okay, and what do you do in your free time that isn't Postgres related? What are
Well,
your
at the moment,
hobbies?
that's a bit restricted thanks to COVID. I used to do relatively regularly go climbing, mostly in like a gym here, but also like to do more outside. I like to go hiking. I like to do woodworking. Yeah, things like that.
Thank you.
If I may ask, when you say woodworking, what would be the thing that you're most proud of having built?
I don't know what I was most proud of. The last thing I'm working on is like a small writing desk that is like fits in our somewhat constrained space, so you can still walk by but maximize the space. I think it came out pretty well.
Awesome. I would order one if you would make them.
I don't think that's necessarily the best way of using both of our time and financial load.
Perfect. But talking about using your time efficiently, I do know that you recently joined the Postgres core team, so congratulations
Yes.
on that one. Could you please explain us what the core team is, what kind of task it has, and how do you feel about joining?
I think you'll probably get about as many definitions about the core team as there are people in the community. I would say that the core team is like the body that handles things that can't be easily discussed publicly. There are sometimes legal matters. There are like community conflicts that need to be handled. There are sometimes like decisions that have become too contentious or can't be discussed publicly for legal reasons. And the core team is basically the body in which such matters can be discussed and eventually decided. And how I feel about joining, I mean, it is even more work, and I feel like I'm already don't have enough time. So there's that aspect. But I also think it's good for the core team to show, like to renew a bit. Like it has been the same set of, well, nearly the same set of members for quite a while. I think like a few people, like one person left, or two people left since the last time somebody was added, and the person leaving was already like quite a few years ago. So I think it's good for there to be some change. There probably could stand to be some more changeover in who's in the core team over time. Yeah.
Thank you.
Okay, and regarding your work, how is your ratio of what you are working on? What I mean by that is, do you find yourself working more on the open source aspects of the code and contributing back to upstream PostgreSQL, or working on like the product and solutions that whichever employee is working on?
It has changed over time. I think with each change of employer, it has like increased the amount of time spent on open source. These days, it is not quite 100%. There is like internally helping people out, trying to give them feedback in which direction to look at. But like coding wise, it is 100% open source, or I guess there's an aspect of experiments that I'm hacking on locally, and then they don't turn out to be a good idea or not work at all or something, and then I throw them away. I don't know whether you can call that open source because it's on my local disk and then get thrown away. But leaving that aside, it is I only work on open source code.
Great.
And that has been the case for my last employers, and before that it was like it used to be at some point officially 50%, and before that it used to be a third or something. And yeah, I'm now fortunate enough to have a position where I can nearly full-time work on open source.
Amazing. Great.
Yeah, indeed, it is. It is very admirable, I would say. And Having been a little bit on the hackers over the years, I see that you are actually managing a very large volume of input to the mailing list. And since you said you're actually trying to give feedback to internally to people, any tips you would have to new contributors on how to approach Postgres encoding?
I think it's not the easiest project to get your start in. And I think we as a project should work towards making that easier. I think generally, I think the advice I have is fairly general. It is find a project that actually interests you, but also try to define it in a way that the scope is manageable. Like there's often either new contributors either come with, hey, I want to rewrite this part of Postgres in a radical different way, and then they fail, which because it is not realistic to get change like architectural changes in as your first contribution, or even to get them working. And the other set is like another group of people is that those that start with like very boring patches, and then they fail to be motivated because like it turns out that boring things are sometimes not that interesting. And that doesn't go just for the contributors themselves, but also for the people reviewing their patches. If they can't be excited about the change themselves, most likely reviewers and committers won't be super excited either. And I think that makes it hard to like have a very successful feeling around it. So my advice would be to find something that is like you actually find interesting and that you can see other people also finding interesting, and that other people will have a chance to see the value of. And I have some, like I think there's ways to find those products, and it's easier to find those if you have an actual production workload or some production or use of Postgres, because then you can see, hey, I regularly hit this issue, so maybe I can like smooth that piece over, or I see this small performance problem, and it might not be a performance problem that brings down my production system, but it's something I can improve. And because it's not as urgent, because it's not the problem that brings down your system, you have the time to actually get it in and without like a lot of pressure. But it's still something that can actually help you and does likely also help other people. So I think that is a good way to get your start. And if you don't know where exactly those are, one way to get started might just be to run a profile on like your test suite or something and try to see where the bottlenecks are, or depending on how your production systems are set up, even better, get profiles in the production system, so you have like measurable real world data, because those bottlenecks will often be different. Yeah, I think. The last way I suggest is try to find some patches that people have contributed and try to break them. And in the sense of like, if there's a new feature that somebody's proposing or a change, try to think through what are the most likely scenarios in which that change will not work, and see whether it causes a problem, or try to find a creative way of like trying to see, hey, this change makes something more expensive and something else cheaper, so I'm going to see what the worst case performance is that is now like after the change, and see whether that is a problem or not. And please also, if you do that, also report, hey, I tried these 5 things and none of them was a problem, because that is actually very valuable information. Don't just report if it's like, hey, I found this terrible performance problem. Also report if there was none.
Absolutely.
Because that can help give people confidence.
Absolutely. I think that's an excellent advice, especially to new reviewers. Thank you. That was a very, very comprehensive answer. Thanks.
Yeah, I agree that facilitating code reviews is a great way to learn a code base and to help other people, other developers actually be productive, as you can offload work that someone else would have to do. And speaking about available resources and popularity, with the recent growth of Postgres popularity and the movements in the cloud vendors are doing, like AWS Babelfish, do you think that Postgres has a chance to become the most popular database soon? And if not, what would be the main blockers?
First off, I don't actually know what Babelfish is, so I can't comment on that aspect. I don't know whether it has a chance to become the most popular database soon. I think there's the graph, if you look at the graphs, they're still a fair bit off. I think the trend of popularity increasing faster than the popularity of some other databases has a good chance of continuing. I think we probably have to pay attention to a few aspects in the development of Postgres to make that more likely. One of them is to just make it easier to run Postgres in production. I think there are a few areas that are just too hard for mortal people, like all of us, that you can deal with if you have a long lead time, if you have experienced people and there's a lot of time, but that shouldn't be as hard. And one of those is, I think, just generally managing real world replication scenarios and making that easier. I think other aspects are making full use of the hardware capabilities. I think we do have some potential for improvement to run faster on cloud infrastructure, because the storage characteristics of cloud storage are just so different than local storage, and we can improve on that. And given how much of the real world workloads are moving into the cloud, or have moved into the cloud, we should focus on that. And so there's on the storage side there's some on the execution side, there's some on the management side. And I personally think those aspects are a bit more important than just expanding the SQL feature set, because for most people that start using Postgres, the SQL coverage is large enough that they don't hit the problems. But if it's, in my experience, it's more likely that they will hit performance problems in some aspect, or that they hit difficulty in creating a high availability setup, or things like that. So I suspect that that's where, in my opinion, effort is best spent. But I wouldn't necessarily just take my word for it, because that's also aligning with my interests. So maybe my position on this is not fully neutral. Yeah.
Thank you.
No, but I agree with quite some of the remarks there. Definitely, as far as mortalities was mentioned, it's a complicated problem, and I do think that we have several questions coming, more or less related on these areas. And one that comes right into mind is there is a layer that is very, very popular now, which is Kubernetes, and it's used either in premise or in cloud. And what do you think that Postgres need to do to make itself more friendly and more usable, to be the database of choice if you choose to go with Kubernetes?
I'm not a Kubernetes expert, so I don't think I'm super well qualified to opine on this. But from my relatively low information level, what I would say is that making it easier to do fairly automated failover, having managed failover and failback without needing to resync the database, or the data, we having to use PG rewind, which is a fairly expensive procedure. And I think I would guess that the problems fit into the manageability, high availability piece of the puzzle. And I suspect it will often also be about making best use of storage of the type that you have in a Kubernetes setup, because you also often will have not local storage, but like some remote storage, like network attached storage, and then you have some of the characteristics of fast SSDs, because often you will actually have fast storage systems, but you will have them combined with the characteristics of high latency, because like you have the network hub, and that is actually something that's slightly weird to tune to. So I think we can make Postgres better in those aspects. I don't think I don't know otherwise enough what the main problems are to have very specific to communities opinions.
No, but this sounds extremely comprehensive, and actually I think it nails the thing in the head. So thank you.
So I will circle back to the code review questions and ask you about the commit fest process, and what do you think about it, and are there any inefficiencies or changes that you would like to see in that process itself?
Yes, there are changes that I would like to see, but I am not 100% sure I know what those are precisely. I think in my opinion, the commit fest process was kind of a band-aid that we tried to apply, I don't know, 12 years ago, 13 years ago, a long time ago, because like patches were falling through the cracks and nobody looked at them ever. And we kind of formalized it and instituted it to a degree that isn't quite appropriate for something that was just a band-aid. It was, and I think we might be over-relying, like we might not be experimenting enough with changing it to quite actually suit our needs. And it is possible that now that the availability of tools to manage code reviews has changed a fair bit, we might want to go a bit with the times instead of using systems that were not new in 2005. On the other hand, the familiarity to people that have done this for, like, that are working on Postgres, like, and have done so for a long time, is important too. If we make those people unproductive because they have to adapt to workflows that don't quite suit them, it will have a significant cost. So I think it's not an easy thing to solve. And I'm not sure that, or I don't think I myself have a great idea how to solve it, or not to speak even more clearly, I don't have the authority to impose my will on how things go, but I suspect we're going to have to evolve a bit to keep newer contributors like to make them less frustrated, and like to make it more likely that they stay on contributing to Postgres.
Thank you for the answer.
Yeah, thanks. I agree. It's a little bit of a weird system. Sometimes I know in the user group we have to explain what a commit fest is. It doesn't come naturally. But to change a little bit the tone before moving to a little bit more technical questions, can you tell us briefly what is your favorite Postgres feature and what is the missing feature you would wish it had?
I suspect this is going to be a bit centric on what I have worked on, just because that is how at least my personality works. I still think logically coding is a very cool feature. That is partially because I spent like 3 years of my life working on it, or 2 years of my life working on it. So I'm probably psychologically damaged enough that I have to think it's cool just to make it a worthwhile experience. But I think it's a feature that like initially got not as much adoption as I had hoped, but then 4 years later starts to become like a building block for a lot more things. And I think that is what I had hoped when working on it. And I think there's still a lot of areas where it's visible that it was not that is not yet the best form of the feature, that there's lots of work that can be done, and that it's still like the code that I wrote in the first iteration. I don't even know when that was, but for the feature, and that it could be faster, and that it could deal better with certain scenarios. And a lot of people have worked on making logical decoding better over the last couple of years. There has been a lot of work adding better support for large transactions and performance features, and I think that is very cool. And I very much like that I am not really involved in the feature anymore, and I see it is moving ahead, because I think that is the best way it can go, is that you create something and then other people do their thing with it, and it is developing in a good direction. I think the biggest missing feature in Postgres, I think there's a lot of those. I think personally, I would say that good asynchronous I/O and fast storage access is probably one of the most important ones. But that's because I've been working on it for quite a while. So again, I am not necessarily neutral on this, but I think it is I chose to work on it because I think it is very important, and because I think it is interesting. But I do think that at the moment we cannot fully utilize a lot of resources, and we have some issues around. We could have more predictable latency, for example, and especially on systems where the storage itself has higher latency, or on systems where the storage has very low latency, like a server-grade SSD that is local, like an NVMe SSD. We have higher latency than we necessarily have to have, because we don't utilize all the possibilities. And I think we can improve upon that, and it is doable. Otherwise, I probably wouldn't have spent a year working on it.
Well, thank you for the work, both in logical replication and on asynchronous I/O. I think we have some questions following that line a little bit further down.
Oh, cool.
And we also have a perfect segue to the technical questions. So let's start with the 90s.
1 second, there's a garbage truck driving by. I can't hear anybody. I'm sorry.
Okay. Time for vacuum.
Yes. The street is being vacuumed. Now I can hear again. Sorry for that.
Okay, no problem. So let's start with the 90s paper, The Implementation of Postgres, by Michael Stonebreaker, Lawrence A. Rowe, and Michael Hirohama. They outlined a plan, and in that plan, they describe a last aspect of our design concerns the operating system processes structure. Currently, Postgres runs as one process for active user. This was done as an expedient to get a system operational as quickly as possible. We plan on converting Postgres to use lightweight processes available in the operating systems we are using. These include Presto for the sequence symmetry and threads in version 4 of Sun OS. So my question is, how is removing that quick hack of one process per user going?
It has not been going anywhere for a long time. And I think to some degree you can blame Stonebreaker et al. For that, because they layered a lot of dependencies on that. And then the Postgres community did a lot more of that over the next 2 decades, 3 decades, oh God. I do think that we probably cannot escape that move forever, but I think there's not a uniformly held opinion. I do think that to make proper use of hardware and to be able to improve upon a few of the features that we are going to have to move to threads at some point, just because the context switching cost is higher, because we need to have more resources allocated between the threads. We need to have a file handle in each of the processes open, and similar things. And there is a lot of architectural complexity that comes from not relying on threads. For example, especially under parallelism infrastructure, we have a fair amount of complexity to be able to deal with shared memory between processes that is allocated after start. So we tend to have one implementation for a hash table that is used in shared memory, one that is used in local memory, and then one that is used in dynamic shared memory for Power queries. And sometimes there's two for like in different parts. And that is probably not really sustainable. And it makes it harder to understand the system, and it implies overheads. We could be more efficient about how we pass around tuples between processes, for example. And that is hard to do without changing the threading model. But it's also a huge change, and there's a understandable reticence about a change of that magnitude, because it will probably have some stability impact. It will break a lot of extensions that rely on having process separation. We can change core Postgres very comparatively easily because you can just change the code, but you cannot automatically go into all extensions and adapt them and make them safe, and make them safe both when using the Postgres 20 with a threaded version and Postgres 19 with a non-threaded version. And so all of that has some impact. And there's obviously also some stability impact. We do gain some benefits from the process separation. We do also gain some scalability actually by using processes, because the operating system has to do less locking, for example. If one process allocates memory, that is cheaper in the current world than it is in a threaded world, because there's operating system locks that are global to all threads. And currently we don't have to fully fight those, or we don't have to contention on those, and we would have afterwards. But I do suspect we going to have to do it, but it will be a lot of work.
Okay, so I see our chat has woken up and asked some related questions. So maybe before we dive into those, I will quickly ask a follow-up regarding the connection limits, because we have one noted that many people think it's okay that max connections in Postgres can be set to a couple of thousands and it will be handled correctly. And there is a wiki article stating a completely different thing. So there is an old rule saying that one should not go for more than 2 times the number of virtual cores, and Bruce Momingen on his blog mentions that for OLTP this rule is 2 up to 5 times the number of cores. And is this rule still valid, and how your recent changes to Postgres 14 impacted?
I think that rule, to be honest, was never particularly valid. I think there's a bit of a confusion that rules like this are valid in the sense of you don't want to have more queries executing at the same time than 2 to 5 times the number of cores, because then otherwise you're going to get a lot of context switching. But in real world use of Postgres, you don't have queries executing permanently. You have latency between the client and the server. So just if you have an OLTP workload where most of the queries are fast, the latency between the client and the server will be about as high as the query execution time. So by that, even if your application is busy sending queries most of the time, it will still be idle half the time because the query has to be going back and forth. And in more realistic scenarios, your application will not permanently send queries. It will also do stuff like render, like send HTML, or like render HTML and send it out to the client, or do other computations where it receive data. So in a lot of workloads, even that are very database centric, your individual connections aren't that busy, like aren't 100% of the time busy. It is a bit different in analytics workloads where the queries take very long, but in transactional workloads, I think it is very common to have like 90% of your connections be idle. So, which basically means that all the rules around you can't have more than that connections per core, for me, don't make a ton of sense. I think what makes sense to say we don't want to have more queries executed than that, and you can make that as a good approximation for seeing how likely can you scale your workload on the same amount of hardware, is to say, hey, currently I'm have that many active queries at the same time. When will I roughly hit problems? And then you can use this core-based approximation. But for estimating what the maximum number of cores connections that you can have established at the same time, I don't think cores are a very useful measurement. To go to max connections, I would say that before Postgres 14, you could have max connections to some like fairly high, because having max connections high just implies a bit of memory usage. What matters is having connections established. And if you have somewhere around more than 500 to 1,000 connections established, then you start seeing some overhead. And after that, if you have more than that, it gets quite a bit worse, just because there are some operations in Postgres, and the most important one is done whenever you start a query or whenever a query is planned, that roughly scale with a number of established connections. And then there's some like CPU architectural issues around that, where that does not scale super well to large number of connections. And I do hope that I improved those significantly for Postgres 14, but that's not released. So if you are on a released version of Postgres, you probably, if you want to have tens of thousands of connections established, or more than 1,000 connections established, it does make a lot of sense to try to use a pooler if your system architecture can handle it.
And especially, you also have to account for things like parallel query execution, which can mean that 10 connections actually have 100 or 80 active queries. So we have noticed that we have like 20 minutes left. So Georgios, do you want to continue or start asking the chat questions? What's your take?
I would say that there are some chat questions that run very much to the topic at hand. So maybe it's the right time to go for those.
Go ahead, perhaps.
There is one that is a clarification question on what you were saying. That is, it's more like don't run more queries than you have cores, right?
I mean, that is what I think the answer roughly should be. I think you can use more cores than you have queries, because given the way the Postgres execution model is, if you are blocked on I/O, you automatically can, like, it's fine to run something else on the CPU. But the typical advice is actually to set max connections not higher than that. And I think that is the wrong aspect. Otherwise, I think don't run more parallel queries, more queries than you have cores, or like a low factor of that, 1 to 3 maybe, is a good advice. It's just not how it is typically formulated.
Awesome, thank you. And I think a question that also from the chat that fits into it quite nicely is like, do we have any idea when or if connection pooling will be implemented natively? And what are the problem solutions, ideas, thoughts, etc. around it?
I think it depends on what you define as connection pooling. I think at some point in Postgres, we should go to a different connection model in the sense of not having a one-to-one model between a connection and a process or a thread. And it doesn't particularly matter whether you're talking about a process or a thread. There's some difference in overhead, but it's not as large as often described, because like you still have the stack and all that. You have per connection memory allocations. So at some point, we're going to have to change the connection model. So the connection state is dissociated from the execution environment. So you can have a number of threads and a larger number of connections. And we do some scheduling between the two, or where we execute queries on a thread that is ready for query execution. And then that is not really connection pooling in the traditional sense, because you don't have a pool of queries of connections that are not executed in the same way or something like that. But you can handle a larger amount of connection because you're not dealing with one operating system heavyweight object like a thread or a process for each connection anymore. And I think that is the medium to long-term direction we want to go to. Unfortunately, I think that has a dependency on using threads, because it is possible to implement this without switching to threads, but the overhead will just be higher because you need to do things like pass the client file descriptor between processes, and it starts to get pretty expensive. Whereas if you have a threaded query execution, like a connection model, then you can just pass around an integer, which is fairly cheap, and you can deal with the socket, the client socket that way. But I do think that that is something we need to move to at some point, just because it is with the scale that many users of databases have these days, it is not realistic to have small numbers of connections. And with connection poolers, they all suffer from the problem that they don't support the whole host of Postgres capabilities. And that is partially because you kind of need a full connection state for those. So we don't want to have a super slimmed down connection state because we want the full set of capabilities, which then means that we have to change the connection model to be something that is not based on operating system primitives in this thread or process sense.
So there is another chat question that ties into the various types of overhead different threading models have. And the question is, what is your opinion on green threads, coroutines threads per core model for databases? So probably essentially, what would be the preferred approach? Would it be like event-based processing, like a coroutine? How do you see it?
A mix of those. I'm a bit less, let me rephrase that. I think the best connection model for something like Postgres, that is a database that is used in very, very different scenarios, cannot be something like a thread per core, especially not one that is like pinned to that core and then uses like spins on IO or something like that, which that is a very valid model for some databases that are geared towards very low latency, massive scale, but it only is viable if you can take over machines. It is not really viable if you have to minimize your impact on the system, because Postgres is a tiny bit of the workload or something like that, or because it is part of like an application. So there's models to make that work, but like I don't personally think that the thread per core model is fully something that we might want to go for. We might want to make use of like something like it in like some more minimal ways, but I don't think we can fully go for it in the like C star type for a C star type environment, just because it's, I think, not generally applicable enough, and also because it's not something we can easily move to in a gradual fashion, because we cannot just say, hey, we're going to stop releasing Postgres for 5 years and change everything. That is obviously going to lose us all our users, and also most developers would quit. So that is never going to happen. So it has to be a model that we can more gradually move to. And I don't think that is quite possible with like some of the more radical ways to execute queries. I also don't think that an event-based model, purely event-based model, like, I don't know, Redis or something like that, is really suitable for a database where your queries can where it makes sense that your queries can take quite a while to execute, and CPU is often a constraining factor. And at a time when your systems have more and more cores, it is also not I don't think that's like a very future-proof system. But I think you like going for something that is taking some of the aspects of that and having different type of threads where some of the threads are dealing with certain aspects of the system. For example, like a few threads that deal with accepting connections, and other threads that deal with query execution, and changing the executor so that we can realistically swap between query execution at reasonably well-defined points is doable, but it does have a lot of dependencies on larger changes. We do need to move to threads, as we had just discussed. We do probably need to change the query execution model so we don't have a volcano style, like a tree walk-based query executor, because if we are at the depth of a tree, we cannot easily say, hey, we're going to stop execution here and switch to executing something else. It is doable by like saving the stack and switching to a different stack, but that is not a particularly appealing approach. So I think we do want to have a different executor model to be better able to deal with some of that. But that is also a fairly large change. I think I do roughly know what I would like to do there, but and I think a few others have ideas around this as well. But it's a large amount of change. And then the second aspect another aspect that makes this non-trivial is obviously that we want to continue to support a fairly large number of operating systems. So there are some dependencies between that and between like what is a programming model that we can use on Linux, on OS X, and on Windows, and on whatever. And the set of common primitives is not nothing, but it's not huge. And that also means that we have to build up more of our own abstractions over different platforms, and that just costs time.
So I have a feeling that we pretty much cornered ourselves in the threading and connection talks.
Yeah, maybe we should move on to something else.
Yeah, and there are plenty of other questions that are interesting, and I think Georgios will skip some and perhaps move to JIT.
Yeah, I was thinking either that or asynchronous I/O, to be honest, because it ties quite a lot with what you have said, that it's your current passion. JIT is something you have been very involved to, and I would love to hear quite some. And also asynchronous I/O is something I would like to hear quite some. So I'll let you to decide what you would like to talk to more about, Andres.
I'm happy to talk about asynchronous I/O. Obviously, I'm happy to talk about it.
Okay, then I will go with JIT because I think you will be talking about asynchronous I/O in many conferences to come soon. So we will get some opportunity there. So I think, first of all, like for most of the people, can you really explain what it is and how it's different from standard compilation? Pretty much what I'm trying to say is what is the problem it tries to solve, and a little bit how.
It is the way I got started with working on just-in-time compilation is that I was working on experimenting with different forms of query execution to go away from the like tree-based model, and I was noticing that all of it didn't matter because at that point all of our time was spent doing not full query execution but just evaluating expressions inside queries, and that is like something like where column is smaller than that value or something like that, or a plus b plus c, and those types of expressions were the bottleneck in nearly all analytical queries. So I tried to make those faster, and part of that was changing the expression evaluation away from also being a tree walk-based form and going for something, I think, pretty standard, which is like just generating it, converting the expressions into like an opcode-based model, which is basically what nearly all of your programming languages that are interpreted do, like Python or Ruby or whatever. And so we have a small execution model for those kinds of expressions. And but then even if you optimize that a fair bit, you still are left with performance problems. And the way to make that one way to make that faster is to not use interpreted execution, but to go for actual native code. And because we are doing that when running the query, that is a form of just-in-time compilation. So what it does is to just convert those interpreted expressions inside the query into native code, and thus gain some performance. That is the basic feature.
Yeah, one follow-up question that I have. When is it actually happening? It's before planning or after?
It happens after planning. After planning, we have some very crude heuristics when your query will be expensive. And then we, sorry, I got distracted by the chat briefly. Yes, I do have a few minutes to extend. Then we look at the cost of the query and then decide that, hey, this is a very expensive query, so we could try to do just-in-time compilation and then do that necessary work and execute the query. Like do the just-in-time compilation, execute the query using those just-in-time compiled pieces of code instead of the interpreted code. But all of that logic is fairly primitive at this point. It is basically still the minimal version of the feature. And while you can definitely see like performance gains, and like I know the typical cases are like analytics queries that do have like add like a bunch of columns and then do an aggregation or something on that. There you can see a good bit of performance gain, but the potential performance gains are much, much higher. And there's I have some outstanding changes, but there's also a lot of work that other people could help out with to make it faster. And I think there's at least another 2-3x that we can gain. That is one aspect. And the other aspect where it's currently pretty severely lacking is that we currently do all of this just-in-time compilation work and the code generation work every time you execute the query. There's no caching of that, which is, I think, the biggest issue with the feature right now, is that we do work over and over again. That doesn't matter if your query is an actual analytics query that takes 10 hours to process the half a second or whatever it would take to do query execution compilation. Doesn't particularly matter. Just it's very small. But if your costs are off, or some related things, or your query is actually so complex because it uses tens of thousands of partitions or hundreds of partitions, and we have to do slightly different just-in-time compile programs for each of those, then that can be a problem. And we really need to, and I have some outstanding work to make part of that work, but again, that's something that I could really help with. Then we need to have caching for those programs so that we can reuse the next time. And there's like we can do that on multiple levels. We can do something like before optimizing the program that we have generated, we check whether it's in a cache and use that. We can do things like, hey, it is a prepared statement, so we know that we don't have to redo that work because we can just cache it. There's some limitations to that, but we can do that. And then there's the more complicated version of, hey, we do want to have that cache survive across multiple connections and be shared between multiple connections. And I suspect we probably want to have a mix of all of those. That is, when you execute a query, when you execute a prepared statement, then we try to reuse the ones that we have generated for this last time, and that can save some time. And if we execute a query that is not a prepared statement, then we try to look in a shared cache and do that based on the fingerprint of the generated code, which still means it has overhead, but the overhead is much lower because we can reuse avoid most of the cost. And then like a last thing that in that direction that we would really like to improve is that we start query execution without using just-in-time compilation and use a parallel thread, like a thread or a process or a background worker or something like that to do the actual query compilation and optimization. And then once that has finished, replace all the interpreter execution, which then means that you don't have a slower start where we have to do the JIT compilation because it can happen in parallel. And I think that would be a great improvement.
Awesome, thank you. You said regarding time that you have some time to extend. Is that correct?
Yeah, I think about 10, 15 minutes I can extend if that is helpful.
Absolutely. Maybe Adam, you would like to take over?
First of all, there was a question in the Google form, how would one get started wanting to contribute to the development of the just-in-time compilation in Postgres. So I think you briefly touched on that, but where we could, are there any resources or something specific we could point that person at? Do you have something in mind, or perhaps later that we can?
I think the easiest might be to shoot me an email, and I think there's a few threads on the mailing list where I've outlined some of the work, but I don't immediately know of a central collection point. And there's a lot of to-do style notices in the source code that you can tackle. But it might be the easiest to just send me an email and I'll try to point you towards something that you are interested in. Like if you say, I want to make it faster, then the things to look into are very different from I want to add caching, or I want to make the planning of it smarter. There's different, and so on.
So a second question is tying into the UTF collation bugs that happened with replication and with systems that have different versions of UTF collation. So an index rebuild on the other node had a different undiscovered ordering. So my question is tying into that type of bug. Would something like that be possible with the JIT compiler, for example, if there were different versions of LLVM backends on those servers or a different CPU architecture behaving in some different way? Is there a risk in that area?
I don't think, I mean, never say never, but I don't think the same type of problem exists because it is always done on the local node. And it uses the same type, like the same libraries that you use locally. There can be things like, obviously, there can be bugs in LLVM, and then if you do just-in-time compilation, you're exposed to bugs in LLVM. There has been one case where there was a bug in one of the functions that normally wasn't visible because it was using undefined behavior in C, and we just didn't hit the problem. But once it was just-in-time compiled, the compiler could see more context and optimized it based on knowing that it is undefined behavior, and then that bug became visible that it wasn't before, and it was not an LVM bug, it was a bug in something that you had executed before. so yes, you are exposed to bugs in LVM, and there's the small chance, but possible chance for hitting pre-existing bugs in Postgres code or in extension code.
Great. Okay. After you, Georgios.
Right. And I would like to take one last question that we had from the community before. It changes a little bit the direction and goes more to the pluggable storage work, which I think you also have led in quite some way. And the question is there any work on pluggable wall that, for the access methods? Currently, they are limited by the generic wall, if I understand things correctly, whoever asked it. So, but I think it's quite right.
That is true. I definitely think we want to do better than that. There are some hard problems around it because we don't want the identifiers for what type of wall access method is being used to be wide for fairly obvious reasons, because we have a lot of wall records and we don't want to increase the overhead for each wall record. So we cannot use like a large long string or something like that. We have only 1 byte to identify the access method. And that because it is like an extension, it has to be loaded both on the primary and on replicas. So we have to coordinate what is the assignment of those IDs between primary and replica, and that is the hard part. So and it's not an easy problem to solve, and like that is the sole core. The reason why we don't have more extensible wall is this problem of assigning identifiers. What we had discussed in the community a couple times is that we actually won't have fully extensible wall, but what we can have is that an extension can just ask the community, hey, I would like to assign an ID to myself, and we just assign you ID 17 or something, whatever, I don't know which ID we are in core up to right now. I don't know, 15 or something. And we assign them, and then you can just use that as the ID, and then we allow you to fill in the callbacks for just that ID, which then means we don't have a problem of needing to synchronize the IDs between primary and standby, because they are coherent. That is obviously not a very appealing approach, but given that a lot of time has passed without us coming up with a great scheme that is simple enough, it might be the most pragmatic one. And I also think the number of extensions that actually need to emit wall is not going to be very large. That is my estimate. Because we're going to have like 2-3 different access methods that are actually going to be good and need that, and we can probably assign a few more IDs than that, and without too much problem. And then once we have a few of those, then we can probably overhaul the system to be something more appealing.
Yeah, that was a little bit the question I was about to ask. Like, what are the access methods currently that you're aware of that they need wall besides heap, obviously?
I mean, I know that there's ZStore, which definitely could be improved with custom wall. There's still some work on zheap that definitely, when I was working on it, it had had patched Postgres to have its own redo functions. There is a few index access methods that could benefit from their own wall. There is 2 other column store implementations that I am aware of that could benefit from that. Although for some of the column store that are more bulk oriented, I think the overhead of the generic wall is actually not a huge problem, because you just write bulk data anyway, so the record would look fairly similar. The benefit of more custom wall is if you have small changes, And currently, the generic wall forces you to emit like complicated binary for like complicated like just the raw data instead of doing something more smarter than that. And that is more a problem for OLTP type data or for data that can be modified in a very granular way, like an index. We might just want to change like a tiny bit of the page instead of having to log a new image of the page and things like that. I've wanted to use it in an extension or two for some, like to be able to integrate more custom data into logical decoding, but that is actually a more complicated question because we don't just want to make the wall extensible, but we also want to make the decoding of the wall extensible. And that is an additional set of problems that we currently don't have, and probably requires some architectural changes or some cleanup of how logical decoding reads data from the wall and move that also more into the callback model that we currently have for access methods.
Right, thank you. I think we have a little bit exhausted the time that we had, and we have plenty more questions written down to ask you. So thank you for being very, very thorough. I really, really enjoyed it. But maybe we should try to get any questions from the audience, if we can spare a few minutes, if there are any.
Looks like
you can raise your hand.
Cool.
Pelle had, someone says, Pelle had one. Will Postgres ever use anything else than the local file system as storage, in particular ZFS objects stored directly, not using the file system, would be very interesting. That's a question.
I don't know whether core Postgres really would want to do that. We want to be able to stay portable to different platforms, and something like ZFS wouldn't necessarily be that. And we want to keep the complexity of Postgres at a manageable level. So we don't necessarily want to add features, complicated features that are like tied to something more that specific. I think I can see trying to work towards making it easier for like there to be an access method that is tuned towards using ZFS, and then that might store its data in a specific form.
Right.
And I think there's some core changes that you can make to make that kind of thing easier. I mean, you can already do that. You can write an access method that doesn't use shared buffers.
Right.
Access the data directly, and I think that can be useful in some situations. I don't know which of those we would necessarily want to have in core Postgres.
Right. Yeah. It makes very much sense. Thank you. I see a raised hand.
Yeah, I've raised the hand. Like, just one question, if I can, because like actually the most common problem, like on Postgres, because I've been like working a couple of years as a Postgres consultant, and like this is just auto vacuum. Like auto vacuum is just running, for instance, like 11,000 times a day on a table that is like really small, but is heavily updated. And it's like focusing on this really little table. And, I think that default settings are really wrong. So I always like change like the defaults for like, the threshold setting to 10,000 or 100,000. So I'm aware that there is like a huge discussion on the Postgres mailing list, but I see that's like really a common problem, and why that's not done yet in the Postgres core.
I think there's different aspects to this. One is that there are some legitimately hard trade-offs to make around auto vacuum, where like different people want different things. For example, tuning it to 10,000 tuples as a minimum threshold will, in some workloads, be terrible, because if you have only like normally one page of data and you tune the threshold to be that high, suddenly some queries might be drastically slower, because suddenly like the amount of data they have to scan is that much larger, and the actual cost of the vacuum can be very low. But on other workloads, what you do can be perfectly sensible. So like one of that aspects is really that it's very workload dependent what is the best setting. And then there's also that there's just different camps, so to speak, in the community that think it should work in a different way. I do think that we made some improvements in Postgres 13, where it finally does vacuuming for insert only workload or insert mostly workloads, which I think is a good improvement. I do think that there are some pretty easy, pretty low hanging fruits about making a vacuum both auto vacuum and vacuum more efficient. We do emit way too much wall, even though we don't actually need to, because for a single page we sometimes emit like 3 or 4 different wall records, even though they could all be combined. We did make in Postgres 14, Thomas Munro and David Rowley did improve CPU efficiency for vacuuming larger relations quite drastically. And I think we can do a lot on that. And at some point we probably need to change auto vacuum to just have the way it schedules work is just fairly naive. And at the moment, it's hard to improve the scheduling in a focused way because we don't have a great data representation or a queue of work representation. And I think we're going to have to improve on that before we can make larger scheduling improvements.
Yeah, that's fair enough. But like what I'm seeing, like really on each system that I do audit, it's like the auto vacuum hangs on this really little table, which is like 10 or 20 megabytes in size, and it's like auto vacuuming. It's all over, like totally neglecting like those huge tables.
Like
sorry?
if your small table is actually changing that rapidly, it might be the right thing to run tens of thousands of times a day, because otherwise it might be might be a few gigabytes large, and if it might prevent your plans from scanning it efficiently as the inner relation of a query plan.
If it's like
a bit hard to know what exactly without knowing more about the workload there.
Sure, fair enough, but like still, those like big tables are like left alone, like without any vacuum or analyzed like for a year, for instance, like in that case.
That is, and that relation has changed.
Yeah, the relation has changed, but the percentage of the changes is much lower than, right?
I think sorry for interjecting, but I think I noticed a change in how vacuum prioritizes tables. Like it used to go from the order of how they were defined, and now it is based on the amount of relation pages it has. So it should take the largest one first, I believe, when you run VacuumDB, for example.
I'm not aware of this change, to be honest.
But I believe it's only for like VacuumDB, not auto vacuum. But perhaps a similar change should be made, like when deciding which table should fire auto vacuum first.
I think this might be a question that's easier to discuss with like statistics and like in writing, just because we kind of need access to the reasons what the problem is.
Yeah, absolutely.
Right. Sorry that I couldn't answer more.
I think you have done an excellent job on answering most of the questions, and thank you very, very much for your time and patience. It has been, at least for my side, extremely nice to see such an early and immediate response when the request was made, and I really want to thank you for giving the time.
No worries. Thank you.
Also appreciate it. It was a very interesting talk, and thank you for joining us.
Thank you for the questions, and thank you for listening, everyone, and have a good, I guess, most of you afternoon or evening. Bye.
Thank you. Bye-bye.
See ya.